Hey guys, and welcome to this video. So in this video, I'm going to give a high-level overview of the OSI model. Just to recap what we talked about in the introduction, a modern networking has a history of over 60 years. A network is really just an interconnection of many devices. Networking models were created to simplify development, design, troubleshooting, and made the components modular. Protocols define rules for formatting and processing data, and this is how the various components of the networking models are implemented. Many competing models were created, which led to interoperability issues, and open networking models were created to fix interoperability issues. One of the most well-known open networking models is called the OSI model. So let's talk about the OSI model. Now, the OSI stands for Open Systems Interconnect. It was created by the International Organization for Standardization, or ISO, in the 1970s. Its main goal was to create an open and vendor-neutral networking model. This is accomplished by defining a set of standard networking protocols that anyone can implement and use. This increased interoperability as vendors can now create products that communicate with each other. And that led to increased competition because vendors no longer have to worry about the networking stack, and it frees them up to innovate on the application side. Now, the TCP/IP model is a competing networking model with similar goals. The reason OSI model did not catch on is due to a slow standardization process. However, the OSI model defined many concepts and terminology that are widely known by network engineers today. So we're going to talk about the OSI model. The OSI model breaks up the network communication process into 7 components, and they're called layers. And these layers are stacked one on top of the other, like the diagram on the right. And the bottom layer is layer 1 to layer 7 at the top. Starting with layer 1, we have the physical layer. Layer 2 is called the data link layer. Layer 3, network layer. Layer 4, transport. Layer 5, session. Layer 6, presentation, and layer 7, application layer. Let's do a quick comparison between the OSI model and the TCP/IP model. And notice that there have been one minor revision to the TCP/IP model, and I've included both here. Starting from the top, we can see that the OSI model defines the session, presentation, and application layers. In the TCP/IP model, it combines all those 3 layers in the OSI model into a single layer called the application layer. Next, layer 3 in the OSI model is called the network layer. Now, in the original TCP/IP model, that layer is called the internet layer. However, in the latest TCP/IP revision, it is now called the network layer. At the bottom, the OSI model defines the physical and data link layers. In the original TCP/IP model, those 2 layers were combined into the link layer. However, in the latest revision, that has been separated into the physical and data link layer, just like the OSI model. So the major difference between the OSI model and the latest revision of the TCP/IP model is at the top, where the OSI model defines 3 separate layers: session, presentation, and application layers, while the TCP/IP model only defines the application layer. For completeness, I'm going to use the OSI model to talk about those 3 layers: session, presentation, and application, as there are some interesting protocols. So now let's talk about how the layers of the OSI model interact with each other. Now, due to its stacked nature, the interaction is actually fairly simple. You start with layer 7, or the application layer, at the top, and move your way down to layer 1, which is the physical layer. And once you get to the physical layer, you prepare that data for transmission, and you send that data over to the destination, and it travels back up from layer 1 to layer 7. During the communication, each layer on one device works together with the corresponding layer on the other device. So for example, from the sender side, let's say you have a payload from the transport layer. Then at the destination, the same protocol on the transport layer will process that payload. Let's take a look at these interactions in a little bit more detail. Now, a layer only interacts with the layer above and below it, and each layer provides a service to the layer directly above it. An interface is provided by each layer as a means for the layer above to request its services, and the layer providing the service adds headers and trailers to the payload passed to it from the layer above, and in a process called encapsulation. Let's visualize how this works. So we start with application data. And when an application needs network access, it's going to pass its data to layer 7 protocol or an application layer protocol. And that protocol is going to add a header and then request services from layer 6. And layer 7 is going to pass its payload down to layer 6, and layer 6 can add its own header. Then it'll pass down to layer 5, and layer 5 will add its header, and so on and so on and so on. When it gets to layer 1, that payload gets turned into a signal and sent to the destination. Now notice that in layer 2 we have both a header and trailer, and we're going to talk about that in a future video. When the signal reaches its destination, the reverse happens. So each layer processes the layer's header and removes it in a process called decapsulation. Let's visualize how this works. So at layer 1 at the destination, it's going to receive the signal. Then it's going to take that signal and turn it into a payload that it will pass to layer 2. At layer 2, it's going to take off the layer 2 header and trailer to process it and pass the payload into layer 3, and so on until it gets to the raw data. So that's how the layers in the OSI model interact, and this also applies to many other layered model approaches. So there's one last bit of terminology that we need to cover before we wrap up, and that has to do with unit of data. A unit of the payload plus the header and trailer for that layer in the OSI model is called a protocol data unit, or PDU, and the OSI model names the PDU for each layer based on its layer number. And you can see here, it is very straightforward. So in layer 7's PDU is called L7 PDU. For layer 6, L6 PDU, and L5, L4, L3, and L2 PDUs. However, terminology from TCP/IP model is more popular. And as you can see here, the layer 2, 3, and 4 PDUs are called the frame, packet, and segment respectively. So going forward, I'm going to refer to a layer 2 PDU as a frame, layer 3 PDU as a packet, and layer 4 PDU as a segment. And that's it. These are some of the references that I used to make this video, and thank you guys all for watching. Please like and subscribe and comment down below. Let me know if any of the concepts is new to you and what layer you'd like to learn more about. And I'll see you guys in the next video where I will talk about OSI model layer 1, which is a physical layer.